There are 2 trillion galaxies in the observable universe, and almost none of them look like ours. Some are empty, some are dead, some eat their neighbors alive. Section 1. Dwarf galaxy. Start at the bottom. A dwarf galaxy is the smallest thing that still earns the name. The faintest ones hold only a few hundred stars, which sounds impossible when the Milky Way carries somewhere north of 200 billion. Imagine a city of 10 million people, then imagine a bus stop with 3 people waiting at it. That's the gap. And here's what makes them matter. There are more of these than anything else out there. For every large galaxy we can see, dozens of dwarfs orbit around it like moths around a streetlight. They are the raw material, the bricks. Every large galaxy in the sky, including this one, was assembled out of the corpses of hundreds of them. Section 2. Irregular galaxy. But not every galaxy that survives keeps its shape. Roughly a quarter of all galaxies have no structure at all, no arms, no disk, no core worth naming. Astronomers call them irregular, which is a polite word for wrecked. The 2 most famous ones hang in the southern sky, the Magellanic Clouds, close enough that you can see them with your eyes on a dark night and mistake them for torn-off pieces of the Milky Way. In a sense, they are. Something pulled them out of shape, and that something has a name. Trailing behind them across the sky is a stream of hydrogen gas ripped clean out of their bodies, stretching more than halfway around the celestial sphere. Our galaxy did that. It's still doing it. Section 3. Spiral galaxy. So what does a galaxy look like when nothing has torn it apart? It looks like the shape you already picture when someone says the word. The spiral. Arms of blue starlight curling out of a golden core, a pinwheel 100,000 light-years wide. Those arms aren't solid objects. They're traffic jams, waves of compression sweeping through the disk, piling up gas until it collapses and ignites into new stars. That's why the arms glow blue. You're not looking at a structure, you're looking at a wave, permanently caught in the act of building, and the whole thing is moving faster than the mind wants to accept. Out here in the suburbs, the sun is running around the core at roughly 500,000 miles an hour, fast enough to cross the United States in about 20 seconds. It still takes 230 million years to finish one lap. The last time the sun was where it is right now, dinosaurs hadn't shown up yet. Section 4. Barred spiral. Now put a straight bar of stars through the middle of that, and you have our address. About 2 out of every 3 spirals have one, and ours is no exception. A bright rectangular spine of stars driven right through the galactic center. The bar isn't decoration. It works like a funnel, dragging gas inward along its length and delivering it toward the middle. And what waits in the middle is a black hole 4 million times the mass of the sun, sitting quietly in the dark, being fed. Section 5. Lenticular galaxy. Feed a galaxy long enough, and eventually the food runs out. What's left is a lenticular, a galaxy stuck halfway between a spiral and something else entirely. It still has the disk, it still has the bulge, but the arms are gone, smoothed away into a featureless lens of old starlight. There's no gas left to build anything new with. A spiral is a fire with fresh wood beside it. A lenticular is the same fire an hour after the last log went on. Still bright, still hot, but nothing left to add. Section 6. Elliptical galaxy, which brings us to the endpoint. Ellipticals are the largest galaxies in the universe and also the deadest. No arms, no disk. Just an enormous smooth swarm of stars, and the light coming off them is red because every star still burning inside is old. Astronomers have a phrase for these: red and dead. The stars don't orbit in a flat plane the way ours does. They swarm, up, down, sideways, crossing each other's paths in every direction at once, like bees around an invisible hive. The largest of them holds something like 100 trillion stars, 500 times what the Milky Way carries, and nothing gets that big politely. Section 7. Colliding and merging galaxies. Every giant elliptical is a crime scene. They were built by collisions, spiral after spiral, slamming together and losing their shape in the wreck. It sounds like it should be the most destructive event imaginable, and here's the strange part. Almost nothing actually hits anything. Shrink the sun to a grain of sand, and the next nearest star is another grain 4 miles away. That's how empty a galaxy is. When 2 of them collide, the stars slide straight past each other and never touch. What does collide is the gas, clouds slamming together at hundreds of miles a second, compressing, igniting, setting off a burst of star formation that can light up the whole wreck. Andromeda is heading for us at about 250,000 miles an hour. In roughly 4.5 billion years, this happens to us. Section 8. Active galaxies and quasars. And when a merger dumps that much gas into a galaxy's center, the black hole that's been sitting there quietly starts to eat properly. That's when a galaxy stops being a galaxy and becomes a beacon. Matter falling toward a supermassive black hole doesn't drop straight in. It spirals and friction heats it to millions of degrees until the whole disk blazes. The result is a quasar, the brightest sustained object in the universe, capable of outshining every star in its host galaxy combined. And the engine doing it is barely wider than our solar system. A candle outshining a city, seen from the other side of the world. Some of them do something stranger. Twin jets of matter fire out of the poles at close to the speed of light, punching through the galaxy and out into empty space, sometimes stretching millions of light years, far longer than the galaxy that launched them. Section 9. Dark galaxies. Then there are the ones that barely exist. Ultra-diffuse galaxies are as wide as the Milky Way, but hold a fraction of a percent of its stars. Take a football stadium on game day and remove everyone except a dozen people scattered in the seats. By every rule we have, they should have flown apart long ago. They haven't. Something invisible is holding them together, and the current best answer is that these things are almost entirely dark matter. A substance nobody has ever seen, touched, or explained, making up most of the mass of the universe. Galaxies like these are the closest thing we have to holding it in our hands. Section 10. Clusters and the cosmic web. And none of them are alone. Galaxies clump into clusters. The Virgo cluster nearby holds well over 1,000 of them, bound by dark matter and filled with gas hotter than the core of a star. Clusters string together into superclusters. Ours is called Laniakea. 500 million light-years across, holding 100,000 galaxies, and it's a single knot in something much larger. Zoom out far enough, and the universe stops looking like scattered points and starts looking like tissue. Filaments of galaxies stretched across hundreds of millions of light-years, wrapped around voids where there is almost nothing at all. The cosmic web, the largest structure that exists. Every galaxy in this video sits somewhere on those threads. The dwarfs, the wrecks, the spirals, the dead giants, all of it strung along the same scaffolding, built by the same gravity, running on the same clock. If you had to pick one to live in, which would it be? Drop it in the comments. And if you want more of the universe explained like this, hit subscribe.